All right, I've got 2:30 Eastern time over here, so I think it's about time to get things rolling. How are we all doing today? Hopefully you have access to the chat room. Can everyone just type something into the chat room just so I know that you all see it? I'm going to be asking for some responses there. Should see it on your menu. There you go. Brittany, thank you. Should see it on your menu. And if you don't, it might be under the more option. So go ahead and type something in because I'm going to be asking you all some questions. Help me out with the lesson today. All right, got 11 of us here, probably get a few more as we go. But let's go ahead and get started. My name's Jeff Volmer, GMAT instructor. 1 a.m. or 1 p.m.? Oh, well, 1 a.m. I appreciate you staying up so late or waking up really early to catch this. So thanks for being here. Happy to have you here. My name's Jeff Volmer. I'm a GMAT instructor for Manhattan Prep. And, you know, every other month or so, I do one of these prep hours. We have kind of a rotating cast. Free hour here. We're going to talk about one particular concept in a sec, but I just want to remind you of some of the other free options you have with Manhattan Prep. Come join a class. Everyone's welcome to attend the first session of our 9-session GMAT course. No strings attached. Just sign up and you know, show up either to an online class or an in-person class. Hannah coming in from London. We do have a center in London, so you can go take a look at a class in London, or we also have our on-demand interactive course, other ways to get free trials for that too. So take advantage of all these things you have access to. I love seeing that people are showing up from all over the place. I don't know where it would be 1 a.m., far away from where I am, but it's cool that we can all connect here. Here's what I have planned to cover today, a little talk about averages just as a way of getting into weighted averages. Weighted averages, which can be kind of a tricky concept, but hopefully talk about an easier way to conceptualize these and a way to kind of shortcut through all of the treacherous algebra that's often associated with these things. So averages and weighted averages. We got people coming in from Europe, from Asia, from Africa, I assume also from North America where I am. But let's go ahead and turn to an intro question. First question. Everyone do this on their own. Don't submit it yet. Do not submit it into the chat box. I will ask you to do so in a moment. But take a moment to figure this question out. I do promise the questions will get a little tougher than this, but it's good to warm up a little bit and use it as a stepping stone. All right, if you have an average answer, go ahead and send it into the chat room for me. Some of you are sending things to just me. Some of you are sending things to everybody. That is cool. But if you have an answer to this, go ahead and send it in. Cool, I see one answer sent only to me, and that is a correct answer. Keep going, anyone else? More conviction, fewer question marks. Let's take a look at how we can do this. Probably the algebraic way makes the most sense here. Have to know how to determine an average, right? You add up a bunch of things and you divide by how many things you just added up, right? The sum of the terms divided by how many terms there were, and we can go ahead and input the specifics from this question into this. 5 exams, 72, 79, 80, 84, 95. There are 5 exams, total it up. 410 over 5 is 82. Good stuff. Haha. Yes, if only the questions on the GMAT were this nice. But I do want to talk about how we can take some of these nice concepts, okay, relatively simple concepts, and apply them to harder and harder questions. So let's take this answer of 82 as our average of the 5 exams, and let's think about that as, well, an average is a type of center, right? It doesn't mean it's the median, right? 80 would be the median here. 82 is a different type of center, and it's really like the balance point of the 5 exams. And so what I mean by the balance point is, well, you have 3 exams that were below 82. 72 is 10 points below the average, a 79 is 3 points below, and an 80 is 2 points below the 82. If you total those 3 exams that were below the average, you find that they're a total of 15 points below the average. Well, that must mean that the 2 exams that are above an 82 make up a total of 15 points above the average. And from that perspective, you can think of the 82 as a nice balance point that kind of holds the 5 exams here in equilibrium. Okay. Let's think about that balance point idea on this next question. Once again, I'll ask you to kind of hold off on your answers in the chat for now. I'll let you know when I'm ready for them. And if you solve this question one way, think about how you could check it another way. Right? If you can finish a GMAT question in 30 seconds, it's probably worth your time to double check it, make sure you didn't make a silly mistake. Don't want to miss any easy questions on the GMAT. Okay, let me know in the chat box what do you need to get on that next exam to bring your test average up to a 90. Send it in the chat box for me. Okay. Better hope there's extra credit on this 4th exam, right? Dug yourself a pretty big hole. Okay, so if you did it the algebra way, that's great. Try to check it with the balance way. Okay, and if you did it from the balancing perspective, try to check it with the algebra. So here's the algebra first, right? Remember, the sum divided by how many terms is equal to the average. Here's what you know. You know the average is going to be 90 if you achieve your goal. And you have 3 exam scores, but not all of them. So I have an 86, an 88, an 84, and this unknown 4th exam. And then I'm going to divide by my 4 total exams, multiply both sides by 4. You have to earn a total of 360 points on those 4 exams in order to get a 90 average. You have 258 points from the first 3, which means there are 102 points you need to earn on the 4th exam. So let's hope that there's a bonus question and you don't make any mistakes. Okay, here's the way this problem checks out with the balance idea. 90 is the overall average that you want to have after 4 exams, right? So think of the balance as the overall average, not just an average of the first few exams or the last half, the last 2 exams, but the overall average. Your 86 is 4 points below that target of 90. Your 88 is 2 points below, and we went the wrong direction here. The 84 is 6 points below the target. That's a total of 12 points that you need now to make up for on this 4th exam. So you have to overshoot your average by 12 points, which means you need to get a 102, okay? Everybody, let me know in chat if you're on board with this. Give me I don't know if you can hit the thumbs up, but give me a colon and a parenthesis. Let me know you're on board. We're ready to keep going. All right, good stuff. Let's think about this first sentence of this problem. What's your average on the first 3 exams? You can type this in the chat. What's your average on the first 3 exams? Yeah, good, Lorena, 86. And you can do that. You could add them all up and divide by 3 and find that the sum is 86. Or you could see that, hey, the 88 is 2 points above 86. The 84 is 2 points below. Those cancel out, and you're overall at an 86. So tell me why scoring a 94 on your 4th exam won't do the trick, right? Isn't a 94 4 points above 90 and 86 4 points below 90? Can anyone explain to me why a 94 won't do the trick? Because a 94 would be a great trap answer on this question. Go ahead and type in an explanation in the chat if you can. Sometimes these are easier to kind of understand intuitively than to explain. But I think if you really force yourself to explain it, you do yourself a greater service of understanding what's going on in the problem. All right, Brittany says, yeah, you have to weigh that 94 against 3 86s. And let's kind of create a childhood metaphor for why this won't work. All right, I'm gonna connect it back to our playground before we even knew what the GMAT was. Oh, great times. And if you put 3 people on one side of the seesaw and 1 person at the same distance on the other side of the seesaw, like that seesaw is not staying balanced unless those are 3 very small children or something like that, right? That's not gonna happen. What's actually gonna happen is it's gonna tip over and be very unbalanced, all right? And that's what Brittany's saying. You have to weigh that 94 against not just 1 86, but 3 86s. And so we understand gravity, that seesaw is going to tip over. Let's think about this. How could you balance against these 3 people on the seesaw? What's one way you could do it? Well, one way would be to create a mirror image on the right side of the seesaw, right? Go ahead and put 3 people over there, and now we've got a nice balanced system. Of course, you can't do that in this particular scenario because you only have 1 more exam to take. Yeah, you could get 3 94s, and that would counter the 86, 88, and 84 and bring you overall to a 90, but we only have 1 shot. All right, we have 1 exam to make up for all our mistakes in the past. And so what does that 1 exam have to do? What's another way you can balance against 3 people on that left side of the seesaw? Anyone explain what's going to happen here? Where can you put that 1 person? Well, it's kind of a misleading question because the seesaw can't look like this, right? You have to extend it further and put that lone person much further away, okay? So let's connect this back to our exam problem. If you had a single 86, you could balance it with a single 94. That makes sense. You could easily do the sum of those 2 numbers. The sum is 180. Divided by 2 is 90, boom, 90 is right in the middle. And it makes sense that 1 is 4 points below, 1 is 4 points above. What's going to happen if you have 2 exams that are each 86s? What does your 3rd exam need to be to average a 90 overall? 98, yes. And think about that. Each of the 86s is 4 points below the balance, so that's a total of 8 points below. You need to now be 8 points above with your 3rd exam. We just did this one on the other screen. 102 is what you'd need to counter 3. And if there were 4 at 86, well, keep the pattern going, 106. And so there is kind of a systematic pattern here. Think about what that pattern is. How could you describe it? What's the relationship between the numbers in each of these seesaws? Think about this. Like this distance down here is a gap of 4. And this distance here is a gap of 16. Why does that 16 need to be so much greater? Well, because there's more exams here. You have 4 exams here and only 1 exam here, okay? And so the best way to really summarize what's going on here is the ratio of how many occurrences there are at each value. So there's 4 exams here and only 1 exam here. That ratio needs to be offset or reflected by the ratio of how far the individual values are from the overall average. All right. So this 4-to-1 ratio in exams is flipped by this 1-to-4 ratio or 4-to-16 ratio in the distances at the bottom. So let's connect that back to kind of the specifics of this problem. Here's what we've got, okay? We've got 3 tests at 86, 1 test at 102. That's a 3-to-1 ratio. Take that ratio and flip it. Flip it and make it a 1-to-3 ratio. That 1-to-3 needs to represent the gaps from how far this score is from the average and how far this score is from the average. Well, it's not a 1-to-3 in terms of pure points, not 1 point below and 3 points below, but 1-to-3 is of course proportional to 4-to-12. All right, so that's kind of showing how it works in this problem. If you're going to use the seesaw method in this problem, of course, you're not given everything all at once. You need to start putting the pieces into place as you understand them. So here's what we understand. You've got an overall balance point at 90. That's your overall average on 4 tests. 3 of those tests are at an average of 86, and you have 1 final test to make up for the points you've missed. Here's what you know, okay? You know that the 86s are 4 points below, okay? But you don't know how far above you're going to need to score on this one last chance, okay? You also know that you have 3 exams already in there at 86 and 1 exam coming up. That's that 3-to-1 ratio. Now we remember, we take that ratio and we flip it, drop it to a 1-to-3 ratio down here. You know that 1-to-3 is proportional to 4 to something. 4 to something, create your proportion, solve it, and you say that's 4-to-12. So that next exam needs to be 12 points above the balance point. 12 plus 90 is 102. Okay, let me pause there, all right, because this is the key to these weighted average problems. All right, it's this flipping of the ratio. All right, it seems a little bit like magic, but as we've seen, you know, the math holds up. 3 exams, 4 points below. 3 times 4 gives you that total of 12 points below. 1 times 12 gives you that total of 12 points above the 90. And that's how it works. Let me pause there and see if there are any questions before we move on. You guys are killing it. All right. Let's keep going. Let's try this question. More test scores. And hold off on your answers for now. Okay, hold off on your answers. I'll put up a poll in a second. You can let me know what answer you prefer in a moment, but take a moment to figure this one out. I'm going to go ahead and put up a poll, and it'll allow you to enter your answer choice if you are ready. All right, so far early poll data is looking good, low sample size, but if you submitted an answer, you are correct. That's great. Let me know in chat if you solved it with the seesaw method or if you set up the algebra. Again, I think you should know how to do both. Just let me know which way you did it. All right, well, I have at least one believer in my method. I think the algebra is definitely doable. And of course, I would prefer that you know as many ways as possible to solve a question like this. And so the algebra would look a little bit tougher maybe to initially set up because there's a lot of moving pieces. You know that the overall average is 90, okay, on all the exams, but of course you don't know how many exams there are altogether, right? You know that there were 8 exams that the males took, but then there are an unknown number of females taking the test. So not sure how many total exams there are. And then you need to figure out the sum of all the exam scores. Well, I know that 8 men averaged 87, so the total score that they received would be 8 times 87, whatever that is, some big number. And I know the women averaged 92, but I don't know how many of them there were. Again, there were X of them in there. And that should be the algebra, right? It's the sum of all the men's points plus the sum of all the women's points divided by how many exams there were equals 90. That's not the easiest thing to set up. I'm going to admit it, all right? That could give me pause a little bit, all right? You'd want to cross multiply, solve for X, deal with, you know, whatever 8 times 87 is and hope you don't make a simple mistake. Or you could set up the seesaw method. All right, let's think about how the seesaw method would work on this problem. You know that 90 is your overall average, right? It's not just the men's average and not just the women's average, but it's the entire class's average, the entire population's average. So that's going to be our overall equilibrium point. Now, you also know the components that go into that average, right? You know, some people averaged 87 and other people averaged 92, okay? You know that 8 males averaged 87, but what we don't know is how many females there are. Okay, that's okay. I mean, the GMAT can't give you a problem-solving problem that doesn't have enough info. So let's keep writing down what we know. All right, you also know that the distances from each of those component averages are 3 points below 90 and 2 points above 90. Take that ratio, 3 below versus 2 above, and flip it. Now you know that the number of occurrences of 82 and 92, or excuse me, 87 and 92 are in that reversed 2-to-3 ratio. Of course, we don't just have 2 males. If you had 2 males, you'd have 3 females. We have 8 males. And so set up your proportion, 8 males to 12 females fulfills that 2-to-3 ratio. And so your answer should be E, okay? I would say even just setting up the balance beam system like this is enough to rule out answer A, right? Kind of remember the seesaws we had earlier, okay? If you had the same number of people over here and over here, well, you know how gravity works, okay? The seesaw would fall on the left side, okay? So you need to put more than 8 people on the right side to balance it. So you could just kind of use your general logic to eliminate answer A. Precisely how many more than 8? Okay, well, that's where you want this ratio to come in. On harder weighted averages problems, you will actually have to determine precisely the ratio here. Sometimes on weighted averages problems, you just need to know that there have to be more females than males. And that's like all you need to do sometimes, okay? Cool. Let's change this problem a little bit. All right, I'm just gonna alter it just a bit to this. Let's spend a moment thinking about this problem now. This one's a little trickier because there's 2 unknowns. You don't know how many male students there are anymore. You still don't know how many female students there are either. But again, they're not going to give you a problem you can't solve on problem solving. Data sufficiency is another beast, all right? But on a problem like this, the right answer has to be there. If you try setting up the algebra for this one, I think it's even more difficult to come up with all the moving parts, okay? So I'm going to really push you to think about this through the seesaw method or the teeter-totter method. Not sure which word is more fun to say. Again, we know we have a balance point overall of 90. The entire class has an average of 90. And you know that there are some who average 87, the men, and some who average 92, the women. Now, you don't know how many men there are, and you don't know how many women there are, but that's okay, because what you do know is something about the ratios, and the ratio is really all you need to figure out this percentage problem, okay? 3 points below for the men, 2 points above for the women. Again, we have that 3-to-2 ratio. Take it, flip it. You know that not only are there more females than males, but kind of in what percentage or what proportion, okay? And so if you know that there are more females than males, well, then you know that the males make up fewer than 50% of the class. So you could eliminate answers C, D, and E, and now you've just got a better chance at guessing, Okay, so that's kind of the general system of weighted averages, right? If the average is closer to 92 than it is to 87, what that means is the 92 carries more weight. There are more 92s than 87s. Okay, now let's get a little bit more precise. 2 to 3 males, but you don't know if there are 2 males or 3 males, or 20 males and 30 males, or 14 males, or excuse me, 20 males and 30 females, or 14 males and 21 females. But you just know that there's some multiple of 2 males and the corresponding multiple of 3 females. And if you know all the pieces of a ratio, then you know something about the total, right? How many people are there going to be in the whole class? Yeah, 5x students. And so the males make 2x out of the 5x students, 2x out of 5x, 2 out of 5, 2/5 is 40%. Okay, so actually sometimes you can solve these problems even if you're missing multiple pieces of the information when you only have to solve a relationship, right? A percentage is a relationship, not a specific value. And sometimes you don't need as much information to solve for a relationship as you would for a specific value. That's a good lesson to take over to data sufficiency as well. Sometimes when you're just looking for a relationship, you might not need all the information there because relationship information can be hidden in other ways. All right, I got a couple more for us to do. Hope you're on board. Let's move to this one. Make me feel better about not exercising the past few days. All right, go ahead and, hold on one second, pull in your answer. Oh, you know what? Can't pull in your answer on this one because there aren't any answer choices. Type into chat your answer for this one. How about that? Let's think about this, right? You've run 3 miles in 28 minutes. Are you on pace? Are you ahead of pace? Or are you behind your average pace, your goal pace? Yeah, you're behind, okay? Like, you could think about it from a couple of perspectives. Like, let's say you were supposed to run 8 minutes and 20 seconds for all of your miles. How long should it have taken you to run 3 miles? If you were going to run 8 minutes and 20 seconds for every single mile, right? Not speeding up and slowing down, but you're just like a machine on a treadmill. How long should it take you to run 3 miles? Should take you 25 minutes, right? If you run an 8-minute mile, 16 minutes for 2 miles, 24 minutes for 3 miles. But now we're going to add 20 seconds for each of those miles. So instead of 24 minutes, we're going to add 20 seconds 3 times and get up to 25 minutes. Uh-oh, you're 3 minutes behind. That means you have to make up those 3 minutes. Better hope this last mile is downhill. You have to make up those 3 minutes on this last mile. And it's not just you have to be 3 minutes better than you have been. It's you have to be 3 minutes faster than your goal, okay? And so if we were going to draw this out, right, let's think about how this works. You've got an 8:20 overall goal. And what you've been doing is running a little bit slower than that, okay? What is 28 divided by 3? And what's your average for these first, that's good. What's your average for these first 3 miles? 28 divided by 3 is 9 1/3. Or in time talk, 9 minutes and 20 seconds, right? And you have 3 miles here. Let's take a look at this gap, right? Each mile, you've been 1 minute behind. Okay, here's what we know. We know that we've got 1 mile remaining, and it's gonna have to be pretty quick, right? To make up for 3 miles, 1 minute behind each time, a total of 3 minutes behind schedule. Your 1 mile is gonna have to make that up. So here we go, we have our ratio. You have 1 mile left to make up for the 3 miles you've already run. That's that 1:3 ratio. Should do that in a different color or just make it really large. 1:3 ratio here. Oh, that's the text button. Get it together. What do we do with that ratio? We got to flip it, all right? It has to counteract the fact that there's only one of these means you have to make it 3 times more meaningful, okay? So if this is only 1 minute slower than pace, this needs to be 3 minutes faster than pace. Your pace is supposed to be 8:20. This needs to be a pretty fast mile, let me just tell you, okay? Like I said, I hope it's downhill and the wind is at your back and you have a bike, okay? That's the key here, all right? Now you could do this one with the algebra, all right? If you have 4 miles, okay, you're gonna go 4 miles and the average is supposed to be 8 1/3 minutes per mile. This needs to be the total time you've taken. Okay, this is solvable this way. Okay, you multiply both sides by 4 and you should get your total time to equal what? How long do you have to run all 4 of these miles? Well, 4 times 8 is 32. 4 times 1/3 is another 1 1/3. So the total time you have should be 33 1/3 minutes. You've already spent 28 minutes on those first 3 miles. So 33 1/3 is equal to 28 plus whatever time you have left on this last mile, which is 5 1/3, or 5 minutes and 20 seconds, right? 20 seconds is 1/3 of a mile. So the algebra in this case is not too tough, but you can see the balance method working as well. Let's try a different rendition of that problem. Okay. let's say now that the first 3 miles are the same. You're still going for 8 minutes and 20 seconds as an average, but you actually have a total of 5 miles to run. So now you have 2 miles to make up the time that you've fallen behind. Let's think about this. And again, you could do the algebra, or we can try the balance method. So let's set up the balance beam again. And we know that our average again is 820. A lot of things are similar, right? We know we've gone 3 miles at an average pace of 9 1/3, right? 28 divided by 3 is still 9 1/3, or 920. And that's a gap of 1 minute. What else do we know here? Let's figure out what we know. What can we fill in on the left side here? Kedar, that answer is close. You're 1 step off. Okay. Okay, Brittany, thanks. You know that you have 2 miles left, all right, to take care of, falling behind. So you have 2 miles to make up for the 3 miles that you've already run. Figure out that ratio. This one's not a tough ratio. 2 miles to 3 miles. And that means that, well, these 2 miles need to have be further away from your overall average than the 3 miles. Okay, there's fewer of them, so they each have to count more, right? They each have to make up for lost time at a faster rate than how you fell behind here. So flip these ratios. Now that needs to be 3 to 2 here. The 1 minute over corresponds to the 2 component. Let's think about that. 3 to 2 is equal to something over 1 minute. What is that value going to be? What is this x value going to be? Well, it's got to be 3/2 of 1 minute, or 1.5 minutes. So it's got to be 1.5 minutes under pace. 1.5 minutes under 820 is 650. Okay. A couple other ways you can think about this related to the balancing idea that we talked about earlier, right? You're a total of 3 minutes behind your pace, right? You were supposed to run those first 3 miles in 25 minutes. It took you 28 minutes. You're 3 minutes behind pace. You need to make up those 3 minutes in these final 2 miles. You don't have to do it all at once. You can make up 1.5 minutes in each mile. And if you're going to do that, if your goal pace is 820, 1.5 minutes under it, saving 90 seconds would be a 650 pace for the last 2 miles. Cool. How are we doing? It's kind of a lot. I'm exhausting you talking about 5-minute, 20-second mile paces. All right, let's carry this on. I got one more set of problems to talk through. You can really see how these questions can just kind of start stacking up. All right, this one actually has answer choices. I'll let you take a few moments and give this one a shot. All right, let me go ahead and, we have answer choices here. Let me go ahead and launch the poll. Let me know if you have an answer at this point. All right, couple answers coming in, not as uniform this time. Let's go ahead and talk about kind of this problem in general, all right? This is a mixture problem, and, you know, in a sense, so have the other exams, right? Your run of 5 miles is a mixture of different paces, okay? The overall exam average in the class was a mixture of the men's exams and the women's exams, okay? And so a lot of people freak out when they see mixture questions, but you know, it's pretty much the same as what we've been doing. I think people get a little freaked out by mixture questions just because you don't typically break up liquids like discretely into like 4 exams and 2 exams. But I mean, we are talking about milliliters here, and you could think about those as discrete pieces. Okay. So here's the situation. You're dealing with a combination of 2 drinks, okay? And it says when you combine them, the overall concentration of apple juice is 68%. Okay. Well, that's key, okay? 68% is my overall average, balance point, fulcrum, whatever you want to consider it. Okay. And let's think about, we'll call it apple juice. Let's think about the components that went into that mixture of 68% apple juice. Well, on the one hand, you've got drink A at 60%, okay? We've got drink A at 60% apple juice, and we've got drink B at 80% apple juice. Okay, so it makes sense that the mixture is somewhere between 60% and 80%, right? You couldn't have the overall punch be like 90% apple juice because not even drink B is that concentrated. And when you pour drink A into drink B, it dilutes it, right? So it's gotta be between 60 and 80, and it says it's exactly 68%. All right, from that, can you tell if there's more of drink A or drink B? Is there more drink A or is there more drink B? And defend your answer, all right? Tell me in chat, how do you know if there's more drink A or drink B? A way to check is to say, like, what if there were equal parts of drink A and drink B, right? What if I had, you know, equal amounts of drink A and drink B, and I poured them together, right? What should the average concentration be there of apple juice if you had equal amounts? Yeah, it should be 70%, okay? So that would be what we call the straight average, okay? But of course, in this mixture, the average is less than 70%, which means, well, imagine, again, you poured equal amounts drink A and drink B, you got the 70% mixture. How do you get it down to 68%? You actually have to pour a little bit of drink A in, right, to lower the percentage a little bit more, okay? So there has to be more drink A than drink B, and I have some good explanations in here. Because 68 is closer to 60 than it is to 80, right? The 60% stuff has a greater effect, right? Because there's more of it. So less than half of it is drink B. And so again, you could get rid of a handful of answers here. It's got to be less than half B, so less than 500. And now we have to figure out kind of more specifically what we've got. All right, so let's kind of put in our actual amounts. I know some of my stuff is 60% apple juice. I know some of the stuff is 80% apple juice. Let's figure out the ratio here, the ratio between these differences. Type in the chat what that ratio is, left to right. Ooh, I don't think that that's the ratio. I do not think the ratio is 3 to 4. Check it again. Right. You can find the ratio by just using kind of the pure difference values. So yeah, Kadar's got, this is an 8% difference. This is a 12% difference, right? 8 to 12 simplifies down to 2 to 3. What do we do with that ratio now that we have a 2 to 3 kind of distance ratio? Flip it, which means there needs to be more apple juice, or excuse me, there needs to be more drink A than there is drink B, but precisely how much more is going to be determined up here, okay? There's a 3 to 2 relationship. We want to connect that to the total of 1,000 milliliters of punch. So let's call this 3x and 2x. That gives you a total of, I don't know, 5x amount of the drinks. Well, you know 5x is all of the punch. It's 1,000 milliliters. And so X is 200 milliliters. And so 2X is 400 milliliters. Okay, 400 milliliters, 600 milliliters then of drink A. That gives you your 3 to 2 ratio. All right, you could actually do the algebra here and determine the exact same thing. But again, that is a lot of work. And, you know, the chances for making a mistake just kind of increase the more complicated the steps are. Okay. So we would want to answer B here. And again, we could get down to answer A or B just by using some basic logic. Hey, the overall percentage of apple juice is closer to that of drink A. And so we know there must be more drink A than drink B. Drink B is less than half of the mixture. Let's get rid of C, D, and E, and then we can take our chances guessing. Cool. All right, one final question to this, or follow-up to this one. It's similar to this question. It looks like this. And you can use some of the stuff we just did on the last problem for this one. A lot of the seesaw stuff will be the same. All right, let's start setting this one up. Maybe I'll quickly ask you to poll in to see if there are any answers or to see if there are any guesses at this point. Ooh, got a couple answers in, and they're good answers. Yeah. If you pulled in an answer, let me know. Did you guess, or did you set up the algebra, or did you set up the system, the playground equipment? Yeah. All right. Let's set this thing up so we can kind of quickly go through what we had on the last problem, because you're going to need that information to kind of think through this one. We'll do this one by hand, which is only fair because I know all of you are doing this by hand too. Okay, we've got our balance system. I know my overall average is at 68% apple juice. That's made up of drink A and drink B at 60% and 80% respectively. We determined last time that those differences, how far they are from the overall average, was 8% and 12%, which simplified down to a 2-to-3 ratio. That was important because it told us that there was a 3-to-2 ratio in how much drink A there was compared to drink B, right? There might be 3 liters of drink A and 2 liters of drink B, right? This time we don't know the total liter amount, right? There might be 3 cups of A, 2 cups of B, okay? But we know that there's a 3-to-2 relationship. All right, so now we want to think about this from the perspective not of the apple juice, but of the orange juice. This is where it gets tricky, okay? Because in all the problems that we've worked on so far, we knew this was apple juice, okay? We knew what the balance point was. And in this question, we actually don't know the balance point. That's what we're trying to figure out. What percent of the punch, the whole mixture, is orange juice? But here's what we do know, okay? I know that there's drink A, and you could set this up A, B, left to right, or you could say, I know drink A has 40% orange juice and drink B has none, okay? It really doesn't matter which side you set these things up on, just like it doesn't matter which side you view a seesaw from. So let's go ahead and just set them up like this, A to B. I know that the orange juice in A makes up 40%. And I know the orange juice in B, well, there isn't any. It's only apple juice and grapefruit juice. And somewhere, the overall percentage of the punch has to be between 40% and 0%. So all these answers are between there. That's not a lot of help at this point. But what else do you know? Right? What else do you know? Well, that was the whole point of doing this seesaw. You know that drink A comes in a 3-to-2 ratio with drink B. Again, 3 cups to 2 cups, 3 drops to 2 drops, 3 gallons to 2 gallons, you don't know. But the ratio is 3-to-2, that's all that matters, because you flip that ratio, and that's got to be the gap from here to here. Okay. So let's think about where could you move that question mark so that it's, you know, not quite as far from 40 as it is from 0, right? You know it's got to be closer to 40, and you know it has to be closer to 40 because there's more apple juice, or excuse me, more drink A than drink B, right? So there's more drink A, so the average has to be closer to 40% than 0%. So just how much closer? Well, you could think about this total gap, right? This gap plus this gap as being like 2x plus 3x, right? All of that distance has to add up to a total of 5x. And that distance covers a total of 40%, from 40% all the way down to 0%. So if you know that 5x is equal to the total change from 40 through the balance point all the way to the other end of the spectrum at 0%, you could say x is 8%. So this should be a 16% gap. This should be a 24% gap. 16 less than 40 is 24. 24 more than 0 is 24. So this should be 24%. Had some good answers that came in there. I think maybe some of you did the seesaw method. Some of you maybe just guessed, but hopefully we feel a little bit more secure understanding how weighted averages can be used just to kind of estimate, but also can be used to solve kind of completely, more specifically, 24%, not just, you know, more than 20. Cool, that hour went by pretty quickly. I presented you with some pretty hard problems. I have to say there is a problem like this in the official guide problem solving section. It comes towards the end, but it's actually a lot like the previous version of the question. It's actually a lot like this one. And this next one would be an even harder version of it, which the official guide doesn't present, but it's possible that they could make one more difficult. This is how they would do it. We'll go ahead and call it there. Thanks so much for hanging out with me for the last hour. Gonna stick around a little bit, see if there are questions. Otherwise, enjoy the rest of your weekend, or I know some of you are stayed up really late or woke up really early Monday morning to watch this. So I hope you have a great week. Thanks a lot, everybody. I'll stick around if you have questions, but I'm gonna cut off the recording here.